So let's suppose that we have a student group with 5 members, and we're choosing a vice president, a president, and a treasurer. So here, we've got a president, we've got a VP, and we've got a treasurer. Okay, so here we've got 5, 4, 3. There are 60 ways that this can be done. So notice here we have an order on them. We're not calling them first, second, and third, but we might as well be. If we are sticking labels on them, president, vice president, treasurer, that's the same as sticking numbers on them, first, second, and third. In other words, changing the order, shuffling the labels, results in a different outcome. And so here we want to use a permutation rather than a combination. So it's important to keep those straight in your mind. When a permutation, different orderings are counted as different outcomes. In a combination, different orderings are counted as the same outcome. So if order matters, if we want that to be a different outcome, we call that a permutation. Let's move on to another example. Let's suppose that we have an art museum. Has a collection of 7 sculptures. There's only room to display 4 at a time. How many different ways can the 4 sculptures be chosen to display? So you ask yourself, are different orderings of the sculpture considered different outcomes? Well here, no they're not. We're just choosing 4 to be put on display. The other ones are in a back storage room somewhere where the museum goers cannot see them. So here, we're going to choose a combination. So here we're going to choose a combination 7, 4. Okay, and this will be 35. Let's look at a standard 52 card deck of cards. How many 5-card hands contain 5 hearts? Well, how many hearts are there altogether in our card deck? There are 13 hearts total. So if my hand is going to meet the qualifications here of having all hearts, that means it has to contain 5 objects from this group of 13 hearts. So what we're going to do is, how many ways are there to choose 5 from that group of 13? 13 combination 5. Why do we use a combination instead of a permutation? Well, when you're playing cards, is it still considered the same hand regardless of the order that you receive the cards? Yes, you'll pick up all the cards and then you'll put them into whatever convenient order in your hand. It's still considered the same hand. So therefore order does not matter, and we choose the combination rather than the permutation. And you should get 1,287. Make sure that you can do these using the combination, the built-in combination function on your graphing calculator, your scientific calculator. You can do it with the factorials, that's fine too. But if you have that built-in function for combinations and permutations available to you, you want to make sure that you can use it. Now let's look at how many 5-card hands will contain exactly 2 aces and 2 queens. The word exactly here is important. Okay, because that tells us what the composition of our hand is. What we have here is we have 2 aces, we have 2 queens, and we have 1 that is not an ace and not a queen. So now we need to determine how many ways are there to choose 2 aces. Well, how many aces are there in the card deck? 4. How many are we choosing? 2. Is it considered the same outcome if they're in a different order? Yes. So we use a combination 4, 2. How many ways are there to choose 2 queens? Once again, we've got a combination. There are 4 queens in the card deck, and we are choosing 2 of them to be in our hand. The reason we're multiplying these together is because of the multiplication principle. which we've talked about before. So we're going to keep multiplying until we have finished forming our hand. 2 aces, 2 queens. Now the other one is not an ace and is not a queen. How many non-ace, non-queens are there in the card deck? Well, I have 52. Subtract the 4 aces, subtract the 4 queens. Okay, that gives me 44. We have 44 non-ace, non-queens in our card deck. Multiply all these together. You should get 6 for the first, 6 for the second, and then 44. So 1,584. How many 5-card hands will contain 2 hearts and 3 clubs? So we're going to have 2 hearts. We're going to have 3 clubs. And we're going to multiply them together because of the multiplication principle. Okay, how many ways are there to get 2 hearts? Well, how many hearts are there to choose from? 13. So 13, we're going to choose 2 to be in our hand. How many ways are there to choose 3 clubs? Well, there are 13 clubs altogether. We're choosing 3 to be in our hand. So we're going to take combination 13, 2, multiply by combination 13, 3. We should end up with 78 times 286. You can figure these out separately, or if you have a graphing calculator, you can put them in with parentheses around them and do it all in one step. You should get 22,308. Make sure you're using your calculator and calculating these right along with this video, because you want to make sure that you're using your calculator correctly and that you can duplicate these answers on your own. In how many ways can a quality control engineer select a sample of 3 transistors for testing from a batch of 100? Okay, well, is the order going to matter? It's going to be considered the same sampling regardless of the order of the 3 transistors that the engineer selects. So that tells us we're going to use a combination. How many ways are there to get a sample of 3? Well, there are 100 to choose from. Engineer will choose 3, so we get combination 100, 3, 161,700. This is the one where you'll probably want to use that built-in function on your calculator rather than just the arithmetic and the factorial. How many ways can a panel of 12 jurors and 2 alternate jurors be chosen from a group of 30 prospects? So what we're going to have here is we're going to have 12 jurors, and we're going to have the number of ways to get 2 alternates, and we're going to multiply those together. Now, how many ways are there to choose 12 jurors? We're choosing them from a group of 30. Does the order matter? No, it's still going to be the same panel regardless of the order. So we're going to use combinations, not permutations. So combinations, there's 30 to choose from. We're choosing 12. So we get 30, 12. Now, got to be a little careful with the second part. Once again, it's going to be a combination. We're choosing 2 alternates. How many are we choosing from? Are we choosing from the entire group of 30? No, because some of that group of 30 have already been chosen to be on the jury. You can't have the people that are already on the jury also being the alternates. So we really only have 18 that are left, because 12 have already been chosen for the jury. So from the 18 remaining, we are going to choose 2 alternates. Now, when you put this into your calculator, you're probably going to get you should get a very large number. Here's what I got, 3233. Whoops. Okay, our calculators put this in scientific notation because there was not room for all the digits. So remember, when you're doing scientific notation, you can think of moving this decimal over by 10 slots. So 1, 2, 3, 1, 4, 5, 6, 7, 8, 9, and then one more. So 1, 3, 2, 3, 3, 4, 6, 3, 4, 3, and then one more. And then you can put your commas in if you want. But it's also just fine to leave it in scientific notation as well. So either of these would be fine. And we could approximate this a little closer if we're going to leave it that way. Okay, let's do one more example. How many ways can we choose a subcommittee of 4 from a Senate committee of 5 Democrats and 4 Republicans? And we've got a couple different conditions here. First, all members are eligible, so the party doesn't matter. We're just going to choose from our Senate committee of 5 Democrats and 4 Republicans. We're going to choose 4 members to be in our subcommittee. So how many total people are on our committee? Well, we have 5 Democrats and we have 4 Republicans. So that gives me a total of 9 people to choose from. So here we're going to choose 9. From 9 we're going to choose a subcommittee of 4. Is it considered the same committee? If they're in a different order, yes. It doesn't have anything here about ranking them or putting labels on them, so we're going to assume that it's the same committee regardless of order. So we're going to do a combination 9, 4, which will give you 126. Now what if our subcommittee has to consist of 2 Republicans and 2 Democrats? So we have 2 Republicans, and then we're going to have 2 Democrats, and we want to figure out the number of ways each of these can happen, and then we're going to multiply them together using our multiplication principle. So how many ways are there to choose 2 Republicans? Well, we have 4 Republicans to choose from. We're going to choose 2. From the Democrats, we have a group of 5, and we're going to choose 2. And so this should give me 6 times 10, which is 60 possible subcommittees. Let's suppose that we have members of a string quartet composed of 2 violinists, a violist, and a cellist. And we've got a group which is comprised of 6 violinists, 3 violists, and 2 cellists. Okay, so how many ways can the string quartet be formed? Okay, so we've got to have 2 violins, and then we're going to have 1 violist. Violist is someone who plays a viola, which is a little larger than a violin. And then we're going to have 1 cellist who plays a cello. How many ways are there to choose the 2 violins? Well, there are 6 violinists to choose from. We are choosing 2. It doesn't say anything about putting an order on them. How many ways are there to choose 1 violist? How many violists are there? 3. We're only choosing 1. So 3. You could do combination 3, 1 here if you wanted. You'll be punching a few extra buttons into your calculator, but that would be perfectly correct. But just think, if you have a group of 3 and you're only choosing 1, do you really need a combination? No, there's 3 ways that can be chosen. And I have 2 cellists, and so there are 2 ways to choose this one. So we're going to have 15 times 3 times 2, which is 90 possibilities. Now let's suppose one of the violinists is to be designated as first violinist, and the other is to be designated as the second violinist. That should be singular right there. And so here, this time, we are putting an order on our 2 violins, right? And so here we've got a permutation. Permutation 6, 2, multiplied by 3, multiplied by 2. So we get 30 times 3 times 2, which is 180. If you compare this to the answer to part A, does it make sense we have twice as many? Yes, because every time we have a pair of violinists, we're going to switch the order, and that'll give us an extra possibility. So we should have twice as many possibilities now that we're putting an order on those first 2 violins. Another way that you could think of this as is just think of first violin, second, and then your viola, and then your cello. And so you could think of 6 times 5 times 3 times 2. Same thing. Let's suppose that we have a student planning her curriculum, and we have certain qualifications upon her curriculum. She needs to choose one of 5 business courses, one of 3 math courses, 2 of 6 elective courses, and then 1 of 4 history courses, or 1 of 3 social science courses. Okay, how many ways are there for her to choose the business course? 5. How many ways to choose the math course? 3. 3 math courses available. 2 of 6 elective courses. Does it matter what order she chooses them in? No, it's still going to count as the same curriculum. She's still going to have the same courses on her transcript. So we're going to use a combination. Group of 6 elective courses, we're going to choose 2. And either 1 of 4 history courses or 1 of 3 social science courses. Well, what does that really mean? That really means that we have a group of 7 courses to choose from. And how many are we choosing? 1. How many ways are there to choose 1 out of a group of 7? 7. So here we end up with 1,575 possibilities. Let's suppose that we have 12 graduate students applying for 3 available teaching assistantships. And how many ways can the assistantships be awarded if no preference is given to any student? Okay, here we have 12 graduate students. We're choosing 3 to be given an assistantship. Does the order count as a different outcome? No, it doesn't say our assistantships have labels on them, first, second, third, or anything like that. They're all just, they either get an assistantship or they don't. So here we get 12 combination 3, which is 220 possibilities. Now, what if one particular student must be awarded an assistantship? So for whatever reason, we have this one person that is certain. So here we have 2 slots, one for our special student, and then we have a slot for our 2 others. How many ways are there to choose the special student? Only 1. For whatever reason, 1 student has to be chosen. Now, how many are left? Well, he's one of the 12, and so that means there's 11 left to choose from. So out of those 11, we're going to choose the other 2 to get the assistantship. So this time we only get 55 possibilities. Now let's suppose that our group of applicants includes 7 men and 5 women, and there is some kind of a rule that says that at least 1 woman has to receive an assistantship. at least one. Well, we want to think about how this can happen. We can have, in our assistantships, one possibility is that we can have one woman and two men, right? And we're going to have a certain number of possibilities that the 3 assistantships can be awarded this way. But then we're going to have some more possibilities where we have 2 women and just 1 man. And there's going to be a certain number of these. Then also, it's possible, what's the other possibility? We have to have at least 1 woman to get an assistantship. Here we have 1 woman, here we have 2. It's possible all 3 of our assistantships go to women. So we need to figure out the number of ways each of these compositions can happen, and then we will add them all up. How many ways are there to have 1 woman and 2 men? Well, we have 5 women, so there's 5 ways to choose the 1 woman. How many ways are there to choose 2 men? Combination 7, 2. Now, how many ways are there to choose 2 women? As soon as you choose more than 1, you need a combination. So here we have a group of 5 women. We're choosing 2. So 5, 2 gives us the 2 women. How many ways are there to choose 1 man? 7, because I have 7 men that have applied. Now, how many ways are there to choose 3 women? Combination 5, 3, because I have a group of 5 women that I'm choosing from. So we calculate these. We get 105 plus 70 plus 10. You can either write them out separately like that, or if you get good at using the parentheses on your calculator, you can do it all in one step. You should end up with 185 possibilities. I hope this lesson's been helpful in understanding permutations and combinations. Good luck, and I will see you next time.